Welcome to week 6, question 10, logarithmic functions and their applications. The question reads, an individual deposits $275 in an account that earns 2.4% interest per year compounded monthly. The number of months needed for the balance in the account to reach an amount of $A is given by F at A. Part A asks us to find and interpret F at 375. So F at 375 will mean the number of months it will take to reach that amount from 275, given those interest rates. So the first thing we'd have to do then is to substitute 375 into the F at A equation. So we'd have F at 375. That's going to be 500 times ln of 375 over 275, like that. And if we were to solve that, we would get a value of 155.1. And that represents the number of months at that current interest rate of 2.4% that it would take for an amount deposited 275 to reach an amount of 375. And part B asks us if we would expect F prime at A to be positive or negative. So it's asking if the rate of change of the amount would be positive or negative, and with a 2.4% interest over time, I would certainly expect it to be positive. So part C says find and interpret F prime at 375. So F prime being the derivative, how are we going to work on that? Again, we need to identify the function. So when we look at F at A, we see that there's a logarithmic ln A over 275. So we're working with a logarithmic function, and we have the mechanism, the logarithmic rule, for taking a derivative. And let's just have a quick sidebar reminder. When we have the ln of x over y, that is equivalent to ln x minus ln y. Okay, so let's just keep that as an aside. So I think it would help us to find the derivative of this function. So maybe we should do that first, make it look in that way. F at A is equal to 500 ln A minus 500 ln 275. Okay. So then when we take the derivative, let's see what we get here. F prime at A. Now we have to remember that the derivative of ln x is 1 over x. Okay, so that again we're going to put as a sidebar, our little thought bubble. So this first part of the function, we have 500 ln A, so that would be 500 times 1 over A, right, the derivative. And here we have minus 500 ln 275, which is a constant, so we're going to be finding that the derivative of that constant is 0. Okay, so here we can say now, if we tidy this up, our derivative is 500 over A. So for the rest of part C now, we're going to be substituting 375 into that derivative function. And we're going to find that it is about 1.3, which means that it will take 1.3 months for the balance to increase by $1, so rate of change increasing by 1 from 375. So that's 1.3 months.